Hello everyone. So in this video, I will be talking about MCP and how it is helping in the AI systems. Okay. So like as we know, LLMs like ChatGPT and we have Anthropic. So most of these LLMs generally work in isolation. So they are very good at when you provide some data and you can get some insights from those LLMs. And even if you want to ask some generic questions like what is the capital of India, right? So all those information you can get because those information are not changing. So all this information is there on their training data set, and that is why you are getting the answer. But what about if you want to perform some actions, or maybe if you want some real-time data, like if you want what is the current weather today in your city, then that is not something which will be there in the LLM training data. So for that they have to call the some APIs to get the real-time weather data and basically answer the user query. But all those things generally is not inbuilt in the LLMs. LLMs cannot perform any kind of actions like if you want to reply over the Slack automatically by performing some action like composing the message, or maybe if you want to uh, create a new pull request for GitHub. So all those things are not possible, like the tools are not integrated with the LLMs. And the other thing is the real-time data access is also not there. So uh, so how can we do that? Like how can we get the real-time data from the internet, or how can we get access of these tools to perform more actions? So one way is the function calling. So maybe I can talk about it. So function calling allows LLMs to invoke predefined functions based on user experiences. So I think I can show you one great example which I found on the OpenAI API website. So this is the function calling. It says that it enables models to fetch data and take actions. So function calling provides a powerful and flexible way for OpenAI models to interface with your code or external service. And this guide will explain how to connect the models to your own custom code to fetch custom data or take action. So let's say if we want to provide the capability of to the LLM that fetch the current data, fetch the current weather information, and answer the user query. So how can we do that? So here is a very simple code from OpenAI website. Is that like we are just importing few libraries for the OpenAI, and the major thing is the tool section. Here we are defining that we want to create a tool with the type function, and that name of the tool is the get weather, and the description is saying that get current temperature for a given location. And we also specify the parameter, like what parameters this function will take, the function which is the get weather function. So it is taking only one parameter as the location, and we have also defined that location is the required parameter. So all those kind of configs are there for the tools, and you can define that. And also you have to define the get weather function as well in your in the code somewhere, so that it can call. And then it can basically generate the response. So let's say if the user is asking what is the weather like in Paris today, and then it can use this tool uh, to get the answer from this function called get weather. So if I just show you like the flow, how it is working from end to end. So let's say in that from this is the developer and this is the model. So we provided the information like the message and the tool definitions, whatever the tools that we have in the code, we provided all these information to the client. And then let's say we the user is asking the query as what's the weather in Paris. Then the model will decide that okay, it needs to call some tools, and that tool is get weather. Now there can be multiple tools as well, so the model will themselves decide that which tool to call and what would be the argument. So once the model identifies that okay, this is a tool name and this is the argument, it will uh, it will send this request back to the developer. And now we will execute the code, like where we have written the code for the get weather function. it will return the response that okay, in Paris we have 14 degrees centigrade, some temperature, and then we will send this information with the all the prior message back to the model, so that the model can compose the final response. So this is how function calling is helping the LLM to fetch or to call external services with the help of tools. So function calling is the way by which the LLMs are invoking external calls or taking external actions. But the problem here is, if you see in the LLM code, you are defining some kind of config, like you have to define the type, name, description, parameters, and this is very specific to OpenAI. If you see for other models like maybe Anthropic or some other models, these defining can be different for different tools and for different LLMs. Okay, coming back to it. What is exactly happening when you are calling a function call using LLM API? You are defining model specific function schemas, which I already explained here. This is the kind of the model specific schema, and then you are also implementing the handlers, the actual code that executes when a function is called for those functions. So I explained about this function, right? Get weather. This function also you have to implement somewhere in the in your environment, and also you have to create different implementation for each model you support. So this point is also I already explained that for OpenAI this is the implementation. For Anthropic the implementation can be different. Okay, so with this there is a problem of like n cross m problem, where n is the number of LLMs and m is the number of tools. So what I mean by n cross m? So let's say if we have n LLMs like OpenAI, Anthropic, or something else, and we have a lot of tools like Slack, Jira, maybe Weather API, anything, right? So all these LLMs we will have to, the developer have to write custom logic for all these tools for all these models. So if we have n models, m tools, so the developer effort would be n cross m, because for each LLM there is a unique way to write a function calling API for that particular tool. So how can we avoid that? Because like every LLM has its own predefined config to configure the tool, just like OpenAI has, which I already showed. So the solution here is MCP, Model Context Protocol. So the Model Context Protocol addresses this challenge by providing a standardized way for LLMs to connect with the external data source and tools, essentially a universal remote for AI app. So you can assume it like it's a C-type charger, like you can just plug any kind of charger in the laptop, and it can charge the laptop. So previously, like all the laptops used to have different ports like C type or maybe something else, lightning and all those things. But then it all came to an agreement that okay, we will support C type so that any charger can fit into any laptop. So it is similar like that. So it was released by Anthropic as an open source protocol. MCP builds on existing function calling by eliminating the need for custom integration between LLMs and other apps. So this is the architecture for the MCP. So in MCP we have host with MCP clients like Cloud ID tools. These hosts talk to MCP servers by MCP protocol, and these MCP servers can talk with some local data source or can call via some web APIs and can call some remote service as well. So the main part of the MCP architecture is the client. We have some MCP clients and then we have something called MCP servers. And MCP clients are generally linked with some host. I will show one example of like what exactly I mean by MCP client and MCP server. So MCP clients can be like Cloud Desktop, which I also showed you here, and the ID like cursor is there, windsurf is there. All those IDs are supporting MCP clients, and you can use them as the like they have the inbuilt MCP clients. And for showing you the MCP server, so there are a lot of MCP servers. If I just show you a GitHub repo, it is like model context protocol slash servers, and here we have like a lot of folks have created the lot of servers already which you can use. Maybe if I want to show you like the lead code, uh, lead code. So there's already a lead code server as well called MCP server lead code, and here you can, what you can do, you can practice and retrieve problems from lead code, automate problems, retrieval solutions, and insights for coding practice. So basically, you can use this MCP server and then query in your natural language via Cloud Desktop or maybe via some other MCP client, and that MCP client will directly communicate with the MCP server lead code and can fetch all the information that you need. So there are a lot of MCP servers. I will share the link of this repo. It has a lot of useful MCP servers, so that would be very useful to you. It has also a Reddit MCP server which is very popular. And if you see here we have all these code, like if I just show you, so here we have all the code. You can check this. It has also all the uh, documentation as well, so it would be easy for you to understand this code. But on a very high level view, we are just creating the server, MCP server, and also we are using MCP client to communicate with the servers. So if I just explain like the overall process, like how MCP clients are talking to the MCP servers and all those things. So I found this very interesting diagram over the internet, which I think would be very useful. I also will link the source of this diagram. Okay, so what exactly is happening? So this MCP client, this can be your Cloud Desktop or Cursor. So when you launch your Cloud Desktop or maybe your IDE, it connects and discover all the MCP servers. So you define all these configs in your Cloud Desktop and your ID, and then based on those values, it searches whether those servers are existing or not, or exist or not. And if it exists, then it initialize the connection and return available capabilities, like what server is capable of, like lead code APIs or lead code server would be capable of lead code thing. Weather API would be capable of fetching the current data, current weather. So all those capabilities, servers return, and MCP clients register all those information with them. And then let's say now user is asking that, okay, what is the weather in San Francisco? Then Claude or whatever the AI that we have recognize that, okay, it needs some data, some external data. So it requests to use MCP capability, and then it identifies that, okay, which tool it need to call, and then it asks for the permission. Like if you can also disable this if you don't want to show permission request. You can disable that as well. But generally it shows you the prompt that, okay, do you want to use this tool or not? Like for fetching the weather API, for fetching the weather, it will show you that, okay, we are calling the weather API. Are you okay with this or not? And once you grant the permission, it will send the standardized request to the MCP server. MCP server will call some external system. It can be some API or some local data store, and then it will return the response. And then again MCP server will again return the formatted response back to the client, and this client will provide this data to the AI, and then AI will basically send the user back with all the contextual answer. So this is how the whole MCP ecosystem is working in a very high level view. Maybe in the next video I will try to create one MCP server and client and try to explain you in a better way. Yeah, maybe you can put a comment like what MCP server or the client you would want to see. I am thinking that maybe I will use the lead code client, which can be helpful. But let me know in the comments what do you think. Thank you.